So the objective of the lesson is basically to understand how to express partial fractions into, how to express a general fraction into its partial fractions. So when I consider a simple example, now let's say here we have 1 over x plus 2 minus, let's say, 3 over x plus 5. And what I do is I basically express this as single fraction. So what I do is if I take LCM of this, I get x plus 2 and x plus 5. And of course, if you take the LCM of the entire numerator and denominator, considering simplification of fraction, what we get is here will be x plus 5 minus 3 times x plus 2. And if you simplify this, what you get is negative 2x. If you open the bracket, it will be x minus 3x, which is negative 2x, and 5 minus 6, which is negative 1, over x plus 2 and x plus 5. So now this you wrote a single fraction from two mixed fractions, two fractions. You simplified it to single fraction. So the partial fraction is actually doing other way around. You express a fraction in the individual components of the denominator. That is your partial fraction. So for example, like here you see the denominator is x plus 2, here is x plus 5. So what we do is with some amount of guessing and some amount of mathematical logic and reasoning, we do express this fraction backwards into this format. So let's understand how we do it. Now, first rule that I'm explaining you with partial fraction is, number one is, when we consider the degree of numerator is lesser than degree of denominator. And the second one is, all the factors that you get in the denominator, they are the non-repeated factor, or you can say the distinct factors. So like, for example, x plus 2, x plus 5. So this rule, or like any other additional roots and all we have. So x plus 3. So these are called as individual factors or distinct factors. But if I just put a square, it means x plus 2 has been repeated twice. So that's something which is called as the repeated factor. So this rule that I'm explaining how to express partial fraction the fraction into its partial fractions will be applicable under this condition when degree of numerator is less than degree of denominator, and you have the individual or like distinct factors in the denominator. Now, how do we basically do this? Okay, so what we assume is, you can see that there are simple constants here. So what we do is we take it as like let's say negative 2x minus 1 over x plus 2, x plus 5 as a over x plus 2 plus b over x plus 5. So what we have to do is we basically have to find out the missing constants a and b. So if we had, let's say, the third factor as well. Now let's say if I had the third factor of something x plus 7 as well, I would have taken c over x plus 7. So basically you go on adding up how many individual roots are there in the denominator. So that's something how we express partial fraction. But now our job is not done yet. So I'm just going to go back to the previous example and I'm going to show you how do you find out the missing value of a and b. So when you look at simple expansion here, you get is negative 2x minus 1. You cross multiply these things out here. So you get a times x plus 5 plus b times x plus 2. Now it's simple. If you multiply both the side, x plus 2 times x plus 5, and here also x plus 2 times x plus 5, this get cancelled. It's here x plus 2 and x plus 5. So what we get is, as a result of it, you'll notice that this is what you get in the expression. Now, after this, there are two ways you can do this question, where one is by simple comparison of the coefficients, which is, let's say I take negative 2x minus 1. You open up the bracket, which is ax plus bx plus 5a plus 2b. So what we notice is that we get a plus b times x here and plus 5a plus 2b. And this is equals to negative 2x minus 1. So now what I do is I compare the coefficient of x, which is a plus b, is actually negative 2. And the constant term, which is here, is 5a plus 2b, that is equals to negative 1. Now after this is to solve the equation. So what I do is basically I take this as multiplication with 2. So what we get is, or you can multiply it minus 2 so that you can get the same coefficient. So 2a, so negative 2a, negative 2b, you're going to get as positive 4. And now what you're going to do is if you add it up, this cancels and you get 3a equals to 3. And as a result of that, you get a is 1. Now, once you got a as 1, after this, you can plug in the equation. If I take a as 1, 1 plus b equals to negative 2. So you get, as a result of this, you get is b is negative 3. So you got the a and b, which is exactly the same as this one here. You notice that. And this technique works for all the kinds of partial fractions that I'm showing it to you. But now the second technique is by simply replacing the values. So let's say, which is like I consider like quicker in some cases, but you can't find all the constants sometimes. So it is important that you use the combination of techniques and not depend on only one. Now, what we can do is if I replace x, let's say when I take x as, let's say x, if I take as negative 5, both the sides, what happened is that I'm actually trying to make one factor 0 at a time. So this becomes negative 2 times negative 5 minus 1 equals to a times 0, because negative 5 plus 5 becomes 0, and plus b times negative 5 plus 2. And as a result of this, you notice that this negative 10, positive 10 minus 1, which is 9, equals to negative 3b. And if you divide, so b is going to be negative 3. So this is a easier way in case if you want, if you like this. X plus 2, if sometimes I want to make, I have to still find the value of a. So I make this bracket 0 now. So if I take x as negative 2, what we get is both the sides will be, this will be positive 3 equals to a times 3, and you get a as positive 1. So this fraction basically, now you can see that this particular expression that we had written in the beginning, now I can replace a as 1 and b as negative 3, which is exact same thing what we simplified here. So this is the first type of question on partial fraction. So in this example, what we have is basically this expression needs to be expressed as a partial fraction. So our first step is to write down the main splitting step. So a over first factor plus b over the second factor. Now, obviously, you take this thing other side. So x minus 3 cancels here and 2x plus 1 cancels here. And so what you're left with is this expression, which is a times 2x plus 1, b times x minus 3. First method is collecting the coefficients. So you open the brackets, collect the coefficient of x. If you compare, the coefficient of x is 3 here, and coefficient constant term is a minus 3b is 5. And so what we get is exactly the two simultaneous equations, and you solve them to get the value of a is 2 and b is minus 1. Other way you could have done was taking x as minus half, which gives you b as negative 1 straight away, both the sides, and take x as positive 3, which makes this expression 0, this part 0, and you get the value of a as 2. So this is the first method, first type of partial fraction, where you have distinct roots in denominator, and also you don't have any factors. The degree of numerator is lesser than degree of denominator. So let's take the next type of question where we don't have the degree of numerator. Where we don't have the. So in this kind of question, when you have a repeated factor in denominator, what we do is we start taking first as a linear factor, a over x minus 1 plus b over x minus 1 the whole squared plus c over x plus 2. And after this, what we do is we take all these factors to the right and multiply with each term. So it will become 3x plus 1 equals to a times x minus 1 the whole square x plus 2 over x minus 1. I'm writing out each factor. So b over x minus 1 the whole squared, x minus 1 the whole squared, x plus 2, plus c over x plus 2, and x minus 1 the whole squared, and x plus 2. So now as a result of this, one of the x minus 2 factor cancel, this cancels, then x plus 2 cancels. Now what we get is 3x plus 1 equals to a times x minus 1, x plus 2, plus b times x plus 2, plus c times x minus 1 the whole square. Now in this question, when you look at the technique, what I do is I take x equals to 1 as we took for the last question. And what we get is 3 times 1 plus 1 equals to a times 0, because this becomes 0, so entire thing is 0, plus b times 3 plus c times 0. So as a result of this, we get is b is 4 over 3. Now already we got b value. Now let's take let's make the other factor 0. So if I take x equals to -2, both the sides, what we notice is that we get 3 times -2 plus 1 equals to a times 0 plus b times 0 plus c times -2 minus 1, which become -3 squared, which is positive 9. So this, if I simplify, will be -5 equals to 9c. And as a result of this, c is -5 over 9. Now the problem is that now if you look at here, I made x as -2, I made as x as 1. Now which is the factor that I substitute the third one? So logical reasoning here is that we already have used the two of the constants, like two of the factors. So to find the value of still a, we need to do something. Now, as this is what I was telling, is that you can't rely on one technique. So I use the second technique, but now I have to go back to the first technique of comparison of the coefficients. So let's see how do we do that. Now, what I do is I'm just going to take down to find the value of a. I find out, use the coefficients of x squared, because there is no x squared term here. So I could just write down 0 x squared. So here the coefficient of x squared will be a times x squared. You can clearly see there is no x squared here. There will be c times x squared. So the x squared term we have is a plus c times x squared. And the coefficient of a plus c here is 0 in the left hand side. So as a result of that, you'll notice as a plus c is 0. Now since we got a is -c and we got all this c is -5 by 9, so we get is a as 5 over 9. Other way you could have done was, don't use this substitution technique, set up three simultaneous equations. Just open up the bracket, collect the coefficient of x squared equal to 0, collect the coefficient of x equal to 3, collect the constant terms and equate to 1. And as a result, you'll get three simultaneous equations. If it's technology-based paper, you can solve on calculator directly. Otherwise, you'll have to solve it manually, which is much more tedious process. So that's why I say use the combination or process to solve this kind of question.